Okay, thanks everybody for coming to our intern seminar. And this is our first of a bunch of different interns. This is by Derek Fucich. And as I said, Derek is an undergrad intern. He's a rising junior at Yale University. And they had a program that allowed him to come through Yale funding to spend 8 weeks here to just try and get as broad an experience in research in ecology and evolution in a working environment. So it's been a real delight to have him here. Derek has had some nice previous experience. He was a plover steward. So if anybody doesn't know what that is, these are the piping plovers and other plovers that nest along our beaches. Often these birds need to be protected from recreational activities. And he was working out on Jones Beach, which is out on Long Island, which is where Derek was. And having grown up just north of New York City, I spent quite a lot of time at Jones Beach as a kid, probably disturbing plovers without knowing it. So Derek got a lot of experience there, and that really sparked his interest in research about ecological systems and the conservation of those systems. So he's been here for about 8 weeks. We had started a project this year just to get a sense of what reduced visitation during our nest monitoring might look like, both in terms of effects on the birds and effect on our data. And Eric was interested in doing something independently. So Derek has analyzed these data. And with that, I'm going to turn it over to him. Derek, if you just turn on your video, and you've already shared your screen. So good deal. Derek, take it away.
All right, good afternoon, everyone, and thank you so much for attending. As Rita described before, today I'll be discussing the results of my exploration into whether differing degrees of nest visitation have an impact on our Florida scrub jays or the data quality pertaining to their nesting attempts. Now, as Reed briefly mentioned before, for those who I haven't had the pleasure to meet yet, my name is Derek Fucich, and I've had over the course of my undergraduate experience, I have an interest in possibly pursuing a career in field research. And I view this volunteership as a great opportunity to reassess if this is really the path I would like to go down. And I have to say, whether it be speeding through the scrub on an ATV on the way to my next nest, or exploring the other field sites that Archbold has to offer, or even just encountering the random wildlife encounters around the station, I could say with confidence that I am very much looking forward to taking my next steps towards a career in field research. Now, why might we want to look at nest visitation in the first place? We have noticed that there has been a gradual increase in nest failures over the past few years. And this could be due to our rigorous schedule of nest visitation stressing these parents out. And this also could be due to this visitation allowing for easier predation on our scrub jays nests. Also, we have well over 100 nests this year alone. So if there's no detriment to a more lax visitation schedule, this could allow the avian ecology lab to reprioritize their time into whatever they see fit. Now, in order to speak to these motives that we discussed previously, we have a few questions which could be asked and explored to help us along the way. So we could explore nest success and the causes of why a nest might fail, as they pertain to nest visitation. Also, we could explore if the stresses of nest visitation might be impacting the life history traits of our scrub jays. Also, we could explore if our visitation has an effect on the development of nestlings. Also, we can explore if an increased or decreased visitation might affect the quality of our data. So in order to answer these questions, first we have to break down our active nests into either a control group, which is our normal visitation schedule, which boils down to every 3 days over the 36 days of a scrub jay's nesting period, or our experimental group, which is a scaled back approach. We would be visiting less frequently. Now, what does this nesting period exactly look like? It starts when we find a nest. This is the nest found date, where we find either fibers or sticks in a shrub, which will potentially be the scrub jay's nest. Then after the scrub jay starts to lay on their lay date, they complete their clutch, or the maximum amount of eggs that this bird will have during their breeding attempt. Now, the maximum clutch size of a scrub jay is 5 eggs, but it's perfectly reasonable for them to have 3 eggs or 2 eggs due to energetic factors and also other factors which could be explored later on. After their clutch is complete, they begin to incubate their eggs in order for them to develop and hatch. And again, it's perfectly reasonable for not every single egg to hatch, as scrub jays do have some inviable eggs. And after those hatchlings or nestlings develop into, they do leave their nest in a process known as fledging. And now it's important to keep in mind that once we visit a nest over this interval, it's quite an intrusive process. We're not really looking at a distance. We're actually going up to these nests, peering inside, making sure all the contents are there, which, as you can imagine, might cause a bit of distress to the breeding pair. Now, let's speak a little bit about our experimental treatment and how exactly we scheduled visitations during this scaled back approach. So once a lay date was established, well, after we found a nest, we visited every 3 days until we found eggs in the nest, so that we could have a lay date for this nest. After this, from that lay date, we could calculate, we could estimate the day which the clutch would be most likely to be completed, the midway through our incubation point, a visit at hatching, and a midpoint between hatching and fledging, as well as a day 11 visit. And on this day 11 visit, we take the nestlings and take some measurements pertaining to their physiology, take some blood, and return them to the nest. Now, this day 11 visit also happens with our control group. However, this is just another one of those discrete times where we would visit our experimental nests. And now it's also important to note that for this schedule to be able to be calculated, we must have a lay date to begin with. So nests which were built but abandoned before scrub jays had an opportunity to lay their eggs were just thrown into the control group, since it would be impossible to calculate this schedule. Now, if we were to include all of those nests in our analyses, this would greatly skew the data set. So for that reason, moving forward, all the analyses you see do not include those nests which have been built but abandoned before eggs were laid. Now, diving right into to our overall nest success, we defined overall nest success as nests which had eggs and at least one hatchling made it to their fledged date. And we can see that there's no large discrepancy between the two. There's no statistically significant difference between the two. However, we might gather some more information if we break down that overall statistic into 2 different time intervals. So this first interval that we broke it down into would be our incubation period. So this considers nests which, from the time that they were built up until the end of incubation and hatching. So we can see that the lower visitation group was more successful over this interval. And this is statistically marginally significant. But also, as we might expect, to balance out this overall trend, we see the inverse. We see the inverse trend for the preceding time interval. This fledging interval would be the time after hatching until the fledged date. So we could see that the lower visitation experimental group was less successful during this time interval. So keeping this previous trend in mind, if experimental nests are less successful during the fledging time interval, which is later than the incubation time interval, we might expect them to be failing later on. And this is exactly what we see. In fact, there's there's a very statistically significant discrepancy in the time interval between a nest was found and a nest failed. And as previously mentioned, the experimental group was spending more time on their failed nests. Now, this could be a potential conservation risk, since these experimental nests are spending so much time on their failed nests. This might limit their amount of possible nesting attempts during a breeding period, a breeding season. Yes. Now, what might be the cause of this discrepancy in success? It could be abandonment. We see that the control group has around a 5% of those that failed, of nests that failed, about 5 of those could be attributable to abandonment. Now, it's also important to keep in mind that nests will only be abandoned during that initial incubation phase, because after those eggs hatch, those contents are way too valuable for a scrub jay to just leave them. So while there is that 5% statistic, there is some nest failures during that initial interval for the control group, which we cannot attribute to abandonment. And also, it's very important to note that our experimental group had not a single nest abandoned during that initial nesting phase. Now, this does give some evidence for the claim that our rigorous visitation schedule might be stressing out these birds, making them more likely to abandon their nests. But again, we cannot say anything for certain, and further study must be conducted to make more robust conclusions. Now, if abandonment didn't account for all of the nest failures, we can say that the remainder of these failures can be attributed to predation. Now, again, once we look at the overall statistic, we see that there's no large discrepancy between the two groups in their instances of predation. However, this isn't to say that the statistics are the same for each of those intervals that we examined previously. For example, in the first incubation phase, the control group could have a lower predation rate than in the next phase, but further study must be conducted in order to clarify where this trend lies. So all in all, our lower visitation group was more successful through incubation, but not so until fledging, and that our low visitation group had not a single abandonment during their nesting attempts. And now, in order to make sense of these trends, the circumstances of predation, we must understand the different circumstances of predation over these two nesting intervals. So in that first interval we were speaking of, as you know, dormant eggs don't beg for food, and breeding pairs aren't constantly returning to their dormant eggs to provision them. So it might make it a bit more difficult for predators to locate those nests. However, under a rigorous visitation schedule, this might alleviate that advantage that the scrub jays have, and make it more easy for predators to locate those nests. Also, blue jays, well, there are different suites of predators that might focus on nests during either of those two intervals. For example, we have blue jays which will take eggs but will not take fledglings. So it would be very interesting down the line to investigate how different predators react to nest visitations, and how this might be driving the trends that we've seen. Now, moving on, we also wanted to see if differing degrees of nest visitation had an observable effect on the life history traits of our birds. So we can see that this is so with clutch size. Our experimental low visitation group had a significantly greater clutch size. And while this could be attributable to the stress induced through visitation, since with a greater visitation, birds will be more stressed and divert less energy towards their nesting attempt, there could be other confounding variables to explain this trend as well. Over the 2021 breeding season, we've had quite a number of first-time breeders which occupy smaller territories than more experienced breeders. Therefore, those smaller territories will be less rich in nutrients, and therefore there will be less energy to expend into a breeding pair's nesting attempt. Also, there is some anecdotal evidence that older scrub jays might have larger clutch sizes as almost like a last push to reproduce before their untimely demise. So if there was a higher degree of first-time breeders in our control group or older birds in our experimental group, this could also be perpetuating the trend that we see here. And now, as we might expect, there's a similar trend we see in brood size as well. And since we don't see a large drop-off, we can say that there's no sharp increase or decrease in inviable eggs between our two groups. Now, while the experimental group had a greater clutch size and a greater brood size, we don't see this trend carrying over to the number of fledglings. Now, it's not a significant discrepancy, but still it's notable that even though experimental groups had a larger brood size, they weren't fledging more chicks. So this might be due to either predation, or it could be due to the nestling development within the nest. And in order to try to parse those two different hypotheses, we decided to exclude nests which had a 0% success rate for fledglings, since when a predator depredates a nest full of fledglings, they won't just take one fledgling; they'll take the entire nest. So by excluding those nests which had a 0% success rate for their fledglings, we're essentially controlling for all failures due to predation. And you can see that there's no significant disparity between the control and experimental groups. So therefore, this likely isn't a product of differential nestling development in these two groups. So in conclusion, we can see that our lower visitation group had a greater clutch size and brood size, but did not have more fledglings. And now this could be due to the stress induced upon the breeding pair with visitation, but again, it could be a slew of confounding factors which we've discussed previously. Now, in order to investigate nestling development a bit further, we do have those measurements of the nestling's physiology that we capture on day 11. One of those factors being weight. And now we see that there's no discrepancies between the two, and the weight's pretty up there. So we can say that there's no one group that's consistently having malnourished or starving nestlings. Now, we don't see this trend carry over to hematocrit, however. Hematocrit is defined as the proportion between the red blood cells and the total blood content. Total blood content is comprised of the red blood cells and blood plasma, and the more hydrated you are, the more plasma you have. So if you were to be dehydrated, your plasma would decrease in relation to your red blood cell content, and artificially rising your hematocrit. So to summarize, if hematocrit is greater, you are more dehydrated. And we see that in our experimental groups. While it's a slight difference, it was a marginally statistically significant. So we have our experimental low visitation groups being more dehydrated. So again, this could be attributable to our rigorous visitation schedule, since it's possible that different food sources could react to disturbance in different ways. For example, with increased visitation, it could be so that more nutritious food is more abundant in those disturbed areas. However, there must be some further study to verify those claims. Now, of course, there could be a few confounds here, most notably those first-time breeders that we were discussing previously. Those first-time breeders, if they have smaller territories, there's going to be less quality food for our control group or experimental for either group, which that first-time breeder is within. So therefore, their nestlings will be less hydrated. So again, if there happen to be more first-time breeders in our control group, this could also be perpetuating this trend we see here. So in conclusion, we see that our low visitation group was dehydrated, but they weighed about the same. And there are still some confounding factors which could be at the root of this trend. Now, since these differences are so slight, it's more probable that the discrepancy we see in nest success is due to predation, not the development of the nestlings over until fledging. Now, moving on, finally, we'd like to see how differing degrees of nest visitation might affect our data quality. And this variable gets a bit conceptual, so bear with me a bit. So what we were trying to explore here was the number of days after a nest of either group failed and another nest was found in that territory. Now, from the statistics, we see a marginal decrease in that time interval for the experimental group, which is to say that these experimental groups, after they were found failed, the next nest in that experimental territory was found sooner. Now, this could bring about an increase to our data quality if those nests we found were younger, since that would make our estimates of lay date and other nesting statistics more exact. However, this isn't what we see. We see that although those nests in experimental territory were found earlier, they weren't younger. So there is after speaking to some of the interns, there is a reason for this trend. Since in the experimental group, a nest was last seen viable 6 days before they were found failed, there was quite a big margin there for birds to begin re-nesting during that interval. So therefore, those territories were prioritized. They were prioritized, and all the interns would go and search in that territory for a new nest, which is why we're finding them a bit sooner. But since the variability in when that breeding pair would start in that 6-day interval it's so variable, that didn't mean that those nests that they found sooner were younger. So therefore, if we were to embrace this lower visitation schedule, this would allow us for more freedom to divert our time into whatever we see fit without a major detriment to our data quality because of this large variation we see. So moving forward, there is some more possibilities to extend this research further. If we manipulate the visitation schedule further, we can get more of a sense how those different variables we discussed change with varying degrees of visitation. Also, if this could turn into a multi-year study, we could have almost a continuous variable of nest visitation. And also, as we discussed previously, there are many confounding variables that we could still test to try to see if those are at the root of the trends that we've seen. And luckily for us, from our impressive data set, we have the capability to run these tests. So for another volunteer or intern down the line, these data would definitely be something to look at. And just wrapping up, I'd like to extend my very heartfelt thank you for Dr. Moman for making this all possible. This experience has been great in pertaining towards my future, and just a great confidence booster. I'd also definitely like to thank the interns of the Avian Ecology Lab, every single one of them. for giving me a brief look into what they do and being so welcoming, and had some great memories here. So I'd like to thank them all. And to every single PI or intern that I've met here, you all have inspired me beyond what words could say. I really look forward to seeing your successes down the line, and maybe one day coming back to this amazing place. Thank you very much. And I guess we're going to questions now.
Stop. If you stop sharing your screen, there you go. Thank you, Derek. It was interesting and great analysis of this experiment that we ran this year. I'm going to go to just remind everybody that they can put questions either in the Q&A or in the chats. And there's a question here in the Grace asks, if you were to advise the bird lab what visitation schedule they should use in the future, which would you suggest?
Definitely the decreased visitation schedule. In respects to data quality, it seems to be there's not much of a there's not too much of a detriment to our data quality. So there's no reason why we can't use it there. And also, it seems to be that again, with those two different intervals of the nesting period, whether you increase visitation or decrease visitation, there's going to be that inverse trend that we see. So no matter what we do, there's going to be an impact on the birds. So there is some benefit to scaling back our visitation schedule. So if there's going to be the same outcome, I don't see why we can't do that.
Okay. Any other questions? I don't see one, but Derek, I have one for you. So you saw a lot of students working on different kinds of projects. Did you narrow your interest down into perhaps general ecology or behavior or demography? What do you think your next area of investigation might be?
Well, I definitely still have much to explore. I do have some other experience in behavior, and I'm taking a real liking to it. So I might want to explore this down the line. But again, I still have quite a long ways to go into my undergraduate career and post this. So I'm really looking forward to seeing what else I can learn, and just to try to make my path more succinct moving forward.
There was another question that came in that was, what was your sample size for each group?
Yeah, so altogether, the experimental group had 59 nests at the beginning. And for our control group, we had around 100.
Why the difference?
Well, let's see. Not too sure. I could get back to you on that one.
Okay. Remember what we excluded some nests from our experimental treatment because we didn't know lay dates.
Yes.
That was one.
That's true.
Another question is, do your findings suggest that increased visitation is fine, that there's little cost to the birds for collecting more data?
Yeah, again, while we visit more frequently, again, there's not really more data coming in. It's just we're just keeping better tabs on the bird, examining their contents more frequently. This isn't to say that a more delayed, we're not getting the same data with our less frequent visitation. We're still examining the contents of the nest. We're still getting all of our measurements. But again, going back to my previous answer, we see those inverse trends of nest success. So again, if you're going to have the same outcome in the end, no matter what you do, whether you want to have better tabs on the nest contents, there certainly isn't any downfall to an increased nest visitation schedule. There could be an increased chance of abandonment like we saw previously, but then again, we didn't have too many abandonments in our entire sample size. So there needs to be some more study done to see if this is actually a trend of increased visitation and abandonment.
Okay. Well, thank you, Derek. We appreciate it. It was a great talk, and look forward to interacting with you. Have another week or so in your internship.
Yeah, thanks so much, everyone, for coming.
Thanks, everybody. And we'll be back again at the end of July with more interns from the Bird Lab.